This is a classic case of why you still need to do some earthworks for drainage, even if you are farming in the desert, and even if you are irrigating with another method that's not furrow, in this case drip, and especially if you're growing a crop on beds or furrows. So the impact on crop yield and machinery operations, and hence farm profit, would be quite significant. So just to show you how OptiSurface can be used to help this, OptiSurface was actually developed for this exact problem for our own farm, which we were developing for sugarcane with drip irrigation, and we didn't want to move as much soil as traditional laser grading required. So we developed OptiSurface, which basically uses curved surfaces instead of straight planes that lasers do. And even though the topography looks quite flat, when you're standing out in this field, they'll look very flat, but they're not. Although you've probably got a fair bit of variation in height here, maybe. But yeah, this field looks quite flat when you look at it. This is I'll send you the link to this, but this is gets an 80 hectare field, yeah, 85 hectare field, drip irrigated, and we could have run the furrows this way, but this direction actually lines up with the other fields in the area. And the first thing you can do is we have this irrigation or this drainage analysis, which basically just shows you the depression areas, and the unique part of this analysis is that you can put in furrows, height and a direction. It'll show you where water will pond. So if we do this analysis without any furrows, if this was ticked off, there wouldn't be much water standing at all in this field. This is the ponding depth. So most of it doesn't have water, but once you put furrows in, the water that could normally flow this way out can't flow out anymore because the furrows are heading this way. Even if the furrows are heading this way, you'd still have the same problem. So this tells you the area, the analysis tells you the area that's ponded. It does a little cost-benefit analysis or cost analysis on that problem as well. So with OptiSurface, instead of defining a planar best fit, which traditional laser grading does, we actually define the minimum slope where we'll accept, the maximum slope we'll accept, and how rapidly that slope can change. And we can do that in main slope and cross slope. And we calculate, and this is a calculated design, and you can see that the surface is quite similar to the existing surface. This is the proposed surface, is quite similar to the existing, except each one of these rows in the furrow direction will always be falling with a minimum slope of 0.05%, maximum of 0.3%, and some smoothing. The cross slope, it's not, you can have negative cross slopes because you don't need water to flow that way. So this is the proposed cut fill map. So most of the field is less than 50 millimeters cut and fill. That'll be 90% of the field is less than 50 millimeters, and then 10% we're doing a little bit of work on, a bit more work on. The deepest cut was here. We'd probably we strip that topsoil off that area and remove the subsoil, and then put topsoil back on that area. So another this shows you the difference between a laser design or planar design and OptiSurface design very clearly. So you can see that if you fit a traditional laser plane of best fit through, you'd end up with this line through here. We'd be cutting, what's that? At that point, that's 100 millimeters there. So these, at that point, we'd be cutting like 250 millimeters there. When we use OptiSurface, we end up with these curved surfaces with the minimum slope. That's probably minimum slope there. That's probably the maximum slope there, and there's a smoothing. See how that's a smooth radius around there? That's the smoothing factor affects that. But you can see that it follows the natural topography a lot better. The maximum cut here is only about 100 millimeters, dramatically less. And then if you look at the Earthworks difference between these two designs, the Earthworks for this design is about 750 cubic meters per hectare, whereas for this OptiSurface design here, it's only about 147 cubic meters per hectare. So that's 500% more earth required for this laser design. So that's the benefit of OptiSurface in a nutshell. If you have any questions, shoot us an email or give us a call. Thank you.